Okay, so this is our last section for Chapter 9, Section 5, Scale, Drawings, and Models. So our first scale drawing, a scale drawing. How many dimensions would be in a drawing? How many dimensions, Max, in a drawing? 2D, right, two-dimensional. So a scale drawing is a way to show, usually we show really large things in smaller format, right? Two-dimensionally. Sometimes we show small things though. Have you ever drawn a cell? I'm sure you have, right? You did a drawing of a cell and the parts in it, maybe? Or when you were in 5th grade, did you do the edible cell?
Yes.
Now that wasn't just a drawing, though, was it? That was an actual model, and that's the second topic today, the scale model. So how many dimensions are in, I think, did I just say it? How many dimensions? 3D, right? Three-dimensional for scale models, okay? Okay, so a scale model might be a train. Who here has a model train set at home, or your parents do, maybe? About half the class is raising their hand. At least half the class. Okay, so this is actually a real scale model of a boxcar, and it's in the smallest working scale that is used in the world. It's called Z gauge. I have a little Z gauge. I like tiny things. My husband's the one who's really into trains, but when I saw the tiny ones, I thought they were cute. So we're going to measure this in a moment and see what this boxcar would be in real life, since this is a scale model. Okay? That'll be kind of cool. Before we do, let's talk about scale. We kind of had an intro to this last Friday. When we were dilating things, we multiplied by a scale factor, didn't we? And that's exactly what we're doing today. It's some ratio. The scale is a ratio of the model to the actual, or the drawing to the actual. Okay? It's really important that we set it up the same each time. So we're going to use the most common format, and that is putting the actual life size on the bottom. Okay? Now that could be changed. We could always have the actual life size on the top. But most often it's placed on the bottom, so that's the way that we'll do it. We'll put the actual size on the bottom as we're doing these problems. Okay? We're using a scale drawing first, so this is two-dimensional, and you've probably done this when you've taken a road trip. We're using a map. And your book actually has this example you see here, and you don't need to draw it. It's kind of sophisticated there. If you wanted, you could try to do a quick sketch. They show us Los Angeles, and they show us San Diego, and there is the freeway that we all ride on quite often. It's the 5, okay? And so the 5, according to this map has this scale that's kind of hidden in this key here, right? And it doesn't look like a fraction, does it? It looks more like you would see, sometimes ratios are written this way with a colon, right? And so who can read for us what the scale is, right?
Every inch is 60 miles.
So he says every inch is 60 miles. So if we're going to put the actual on the bottom and the model or the drawing on top, how could we write that scale as a fraction? Can you do it, Riley?
1 inch over 60 miles.
That's it. We're going to put 1 inch over 60 miles. And the question asks us, what is the actual distance from Los Angeles to San Diego if that measurement is 2 inches? So who can finish this proportion we're setting up? Lauren?
Well, you're going to want to have the distance on the map and the actual distance.
Good. And the distance on the map here is 2 inches. So we're going to have 2 inches over the unknown x. Okay, so will our answer be in inches or in miles? 3, 2, 1. Miles, we know that. So let's just throw out the, let's put that down to remember that later. Let's just throw out the units and just see where the numbers are. We have 1 over 60 equals 2 over some unknown. Okay? Now we have a couple of ways to solve this. Probably most of you know the answer already. And so one way to solve it, can you give me a method?
Cross multiply.
Cross product, cross multiplying. And another one would be? just remember how we blew fractions up with some common factor, right? By blowing them up, I mean 1 times what equals 2? 1 times 2 equals 2. So 60 times 2 equals 120, right? So you could just blow things up that way when you have easy factors like this, easy fractions. Otherwise, let's go back and look at cross products, which is what Ryan mentioned. We could bring the 60 this way, times 2, and the 1 times x. So 1 times x is x, and 60 times 2 is 120 using cross products. Okay, very good. Back to this little train. Who wants to be here measuring this? Nick, will you come up? Okay, so we're going to ask Nick to come up here and measure this. The Z gauge has a scale of 1 to 220. Which of those numbers represents actual life? 3, 2, 1.
220.
It's the 220. Okay, so he's going to come over in this so it can see you. You're going to measure this in inches so we can see how long the boxcar is in inches. In the meantime, we can set up the fraction that you just said. 1, we have the model over actual.
2.75.
Did you use the couplings too?
Yeah, I used it.
So don't count the couplings, just count that boxcar. The couplings are those black things that extend, that attach
Two
cars.
inches.
Exactly, two.
Maybe.
Oh, because the end of this ruler has a little space. Do you see that? So, 2 point.
2.5.
Oh, you're looking at the coupling again.
Oh, we had 2.01.
2 let's say 2.2. 2.2. So we have, the model is 2.2. So where does that go in this fraction? Thank you, Nick. Where does that go? Top or bottom? It goes to the top. It's the model. 2.2 over, we're trying to find actual. And remember, this is in inches, okay? I see no units here, so our answer is going to be in inches too, okay? So who can tell me, what is, let's use our blowing up fractions. What do we multiply 1 by to get 2.2? 1 times 2.2. So what is 220 times 2.2? You're doing 220 times 2.2. Who has it?
1, 2, 3, 4, 5, 6.
Faith, what do you have?
484.
Does anyone else have that?
484.
Okay, she says, very good. We have x equals 484 inches. Now, does that sound reasonable? Do we measure boxcars in inches? No, so what might we do instead of keeping this in inches? Hannah? Very good. So can you give us the conversion factor you would multiply by to get to feet?
1 over 12 inches.
Good. Notice the inches over inches helps us get rid of the inches. So we end up having to divide, and this is not too hard because 12 goes into 48 how many times? It goes in 4, that's right. And then we have 4 over 12 left, which is 1/3. We could say 4, wait a minute, 40, right? 40 and 1/3 feet. Okay, if you go do the division, it's 40 and 1/3 feet. Now, does that sound reasonable for a boxcar? 40 feet long? Does that sound reasonable? Yeah. Raise your hand if you've stood next to a real train, real life-size train. Ooh, more people in this class. Good. You know they're big, right? And 40 feet would be decent-sized boxcar. Okay, good. Okay, let's look at this. This is kind of cool because this is a place in Iowa called Strawberry Point. It has a sculpture of a strawberry that is 180 inches tall. So that makes it cool because, like I said, most often models are small, right? We're used to that. But this is a huge strawberry. Have you ever seen a real-life strawberry that big? That reminds me of that book, The Mouse and the Strawberry. I love that book. Okay, so how tall was the actual strawberry? Pause and see if you can set it up. They give you the scale. Who can give me the ratio that shows us that? Charlie, can you give us a scale?
Scale
As a fraction?
is 120.
120 over what? Over 1. Interesting. And so we know this model is 180 inches tall, so where does that go in this proportion? Wesley? Thumbs up if you agree. Is it on the bottom? I don't see everyone voting. And if you don't agree, thumbs down. I don't know how to say that. Where did we say the model goes, Wesley? On the top. Did you put it on the top? No, I think we should put it on the top. We're saying it's 180 inches tall. We're trying to find the actual strawberry. I think you might have wanted to put it on the bottom because it's a pretty big number, right? So you just naturally want to put it on the bottom, but that's not always the way we set things up. We have to keep with the model over actual. Okay, Wesley, can you tell us how to solve this? Okay, so 180 equals, okay, and then how do you get x alone? Divide both sides by 120, and we end up with 1x equals, cancel, and how many 6's are in 18? And how many 6's in 12? 2. So how many inches is that? 3 halves. 1.5. So does that sound reasonable?
Yes.
A strawberry is about 1.5 inches? That sounds reasonable. So I have a question for you. Is the video going? Did the video go? Anyway, can you see this? I hope the video can see this. Is this to scale? 3, 2, 1? No. Why not? Dylan?
An actual dog is like that big.
Well, yeah, but this is a model of an actual dog. So why is it not to scale, Emily?
Yeah, chihuahuas are.
The head is too big, right? Okay. So finding a scale. You were just using a scale. Now we're going to find a scale, which we'll do using this example. You have to write it down. So pause this and write it down. Okay, Juliana, how do we find scale? What was the fraction we were using? Can you give me the words? What over what? Good. Model or the drawing over actual. So in this case, can you give me those values? 20 inches over 48 feet. Okay, so this would be a scale. And we notice we have different units, which is okay for a scale. But could we simplify these numbers? If we can, we should. So who can give me the simplified ratio? Lauren. Good. So don't forget, you must have those words. So a scale may have different units. This is the tricky part today. A scale may have different units, but a scale factor may not. Okay, so a scale may have different units, but a scale factor may not. Okay, it's a scale without units. So be really aware when it asks for a scale factor, you need to make sure that both the model and actual have the same units. So if this is a scale, 1 inch to 2 feet, please convert that to a scale factor now. Okay, notice that we can write that scale as 1 inch over 2 feet, but now we need the same units, so which will you change? Hannah?
I changed the bottom 2 feet.
Good. To what? How many inches are in 2 feet?
22.
Good, so we change it to the same unit. And notice when we do, the inches over inches becomes just 1, right? We can cancel those out. And you have 1 to 24, which is the scale factor, because there are no units. Try writing a scale factor from this information here. 2 inches and 36 inches. Okay, be sure that you simplify your fraction, and the scale factor is 1 to 18. There you go. Have a good time.